Welcome back to Educare Foundation YouTube channel. Today we want to look at this question on how to calculate the discharge of a water body, the velocity area approach using a midsection method. Now, if you want to understand this whole approach, you would want to check the earlier video explaining the whole concept, the two methods, that is the midsection method and the mean section method, and the various methods used to determine the discharge of a water body. Now, we can get that video in the link to that video in the description area. So we want to go into this question and see how we go about it. So the table presents velocity measurement at a gauging station with cross-sectional area drawn in figure 1. So the cross-sectional area, so this is the cross-sectional area of the water body that we are working with. So let's see. In a river downstream of a basin outlet, in an effort to measure the surface runoff from the basin, using the midsection approach and the mean section method. So in this video, we're going to learn how to use the midsection. Then in subsequent video, we'll learn how to use the mean section. All right. And the information provided in figure 1. So this is figure 1. Now, and the table compute the surface runoff from the basin. Now let's see. So using the midsection method, the discharge, the total discharge that we'll be looking for is equal to the sum of the individual discharges. Now, the individual discharge at any section or at any channage of the water body is given by the velocity, the midsection velocity, times the area. Now, the midsection velocity times the area. Now, the area is equal to the depth at that midsection multiplying the distance, the change in distance, the midsection distance. So in this case, we say x2 minus x1 over what? Over 2 plus x3 minus x2 over 2. So we have to generate the midsection. Then when we generate the midsection, so this is the midsection distance. Then we add the midsection distance, multiply it by the midsection length. Then that will give us the area. Then we multiply the area by the midsection velocity. Are you okay? Now in this question, the experiment was done at the 0.2 and 0.8 depth. That was using the instrument to find the velocity of the water flowing through the river. They measured at a depth of 0.2 and at a depth of 0.8. So when they give you such depth, you need to find the average velocity. But in cases where the velocity is measured at a depth of 0.6, you use that 0.6 velocity. But in cases where they give you two different velocities, two different depth of velocities, that is at the 0.2 and 0.8, you need to find what? The average velocity. So the first thing that we are going to do in this question is to find the average velocity. So we find the average velocity. I'm repeating myself. Now, in a situation where the velocity of the water was measured at 0.6 of the depth of the water body or of the river cross section, then we will use that velocity. But if in this case the velocity was measured at a depth of 0.2 and 0.8, So with these two velocities that we have, we need to find the average velocity, right? So the average velocity for each section, that's what we are going to find. So average velocity, and that's what we are going to use for our computation. So this is going to give us 0, then 9.9. So we have 9.9 over plus 4.3 divided by 2 will give us the velocity here, right? So let's find that is 7.1, 7.1. Then here we have 14.1 plus 6.5. So 14.1, 14.1 plus 6.5 divided by 2, that is 10.3. So you do same for the rest of the section, right? So in finding the average, this is what we are going to get. So 24.9 plus 11.2 divided by 2 will get 18.05. 11.8 plus 5.5 divided by 2 is 8.65. Then it goes on, right? And this will be the average. So after getting it, we need to mark out the changes. We need to mark out the changes. So you come to the cross section and you mark out the changes. So it starts from 0. I'm using the red marker. So it starts from 0. This is 1, 2, 2, 0. This is 6. This is 6. So let me draw the change. Then it starts from 2. So 0, 1, 2. So this is 2. This is the change. 2. Then you come to 6, then 10, so 10. Now it's 1, 1, 1 because of the interval. So 0 to 5 means that every line is 1. So this is 7, 8, 9, 10, 11, 12, 13. So this is 13. Then 17, so 15, 16, 17, 17. Then 20. Then 24. So 24 is here. Then 20, so 25, 26, 27, 20. So this 20, this 24. Now, after getting, we need to know the distances. So from 0 to 2, what is the distance? So I'll use this to write the distance. So from here to here, and let me write it at the top so that. So from here to here, the distance is 2. From here to here, the distance is 4. From here to here, the distance is 7, I guess. Then from here to here, the distance is 4. Then from 17 to 20, the distance is 3. Then from 20 to 24, the distance is 4. Then from 24 to 20, the distance is 4. So you need to get these things in place. Very important. Then we find the midsection. So between 0 and 2, the middle is where? 1. So this is the midsection. Then between 2 and 6, the middle is 4. So the middle is 2. 2 and 6. The distance is 4. So the middle will be 2. So 1, 2. So this is the middle. So this will be our first cross section. Sorry, our first midsection, right? Then from this point, then we've already gotten this half of the middle. Then from 6 to 13 is 7. So the middle is 3.5. So 1, 2, 3. So 3.5 is somewhere here, right? So that one will give us another midsection. So these guys will give us another midsection. You see that? Then we continue in that aspect. Now, under each midsection, under each chainage, there was a velocity. So I'm going to write the velocity down here. So this is 7.1, 7.1, this is 10.3, is 18.05, is 8.65, this is what 12, this is 11.75, and this is what 0. Those are the velocities, right? Then let's record their depth. Let me use the black. I'm writing everything down. So the depth here is 4. Can you see that? So I'm writing it here, 4. The depth here is, this is 6. 6. The distance is 2, 2, right? So 6 is 6, 7. How many? So each interval is 0.4, right? So here is 6.4, right? And that is where this guy is 6.4. So I'll write the depth 6.4. Then when I come here, here's 6.4, 6.8. So I'll write it as 6.8. When I come here, the depth is what? 10. When I come here, the depth is also 10 here. When I come here, the depth is 8. When I come here, the depth is 0. So the velocities are the one in red, the depth are the ones in. So we start. So this will be our first chain. So small Q1, first chain. So Q1 will be equal to the formula that I gave. V1 A1. What is V1? V1 is what? 7.1 multiplying E1. E1 is the midsection at this side, which is what? 1. I've already done the midsection. The distance is 2, right? Divided by what? 2, and that is 1. Do you get it? So 1. Then the other half here is what? The other half here is what? 2. Do you get it? Times the depth. What is the depth there? 4. So this is Q1. Then we come to Q2. The same thing, V2, A2. We get it, V2, A2. So V2 is the velocity. What is the velocity there? The velocity there is 10.3. You get it? So 10.3 times the area. The area is the distance at this side, which is what? 2, plus the distance at this side, which is what? 3.5, times the depth there, which is what? 6.4. You get it? Now, after gotten here to be, we come here. Yes. So here was 3.5, means that here is also 3.5. But here we need to create a midsection. The distance from here to here is 4. So the midsection is what? 2. It's 2. So this is the midsection at this side, right? That will be my Q3. So my Q3 is V3, A3. What is my velocity there? Here is it, 18.5, 18.05 times the area. The area is what? 3.5, which is here, and 2, which is this side. So 3.5 plus what? 2 times the depth there, which is 6.8. Then we go to the next section. Now, when we go to this section, the section left here was 2. Then we create a section here. This is from here to here is 3, so that will go 1.5. So 1.5. So this section has been created as our Q4. So our Q4 will be equal to V4 times what? A4. Or Q4, V4 is what? 8.65 times the area. The distance at this side is Distance at that side is 2, and the distance at this side is 1.5 times the depth there, which is what? 10. Are we okay? All right. Then we go to another section. Now, when we made this section, let me change the color. When we made this section was length, which is what? 1.5, right? Then from here to here, we create another from 20 to 24, create another section, midsection there. And the distance is what? 4. So when I create a section there, it's going to be 2, right? So this is 1.5 and this is 2. That will be our new section. And so our our Q5, which is V5 times what? A5. Now Q5, our V5 is what? 12, right? And our A5 is going to be the 1.5 that was left plus the new section that we created, which is 2, times the depth there, which is what? 10. Then with that in place, after creating this section, a small portion was left here, which is what? Which is 2. Then from 24 to 28, the section there will be what? If I create a mid section there, here is going to be 2. And so this is going to be our new section that has been created. And so that will be what? My Q6. And so my Q6 is going to be V6 times what? A6. Now my V6 is what? The velocity there. The velocity there is 11.75. So 11.75 times the area, which is what? 2 plus 2 times the depth, which is what? 8. And that will be the whole shoe. So then I find the sum, I evaluate each, then I find the sum. So let's evaluate and find the sum for each. So this is going to be giving us what? And so this is going to give us see 5.2 right meter cube per second. This is going to give us, so that is 10.3 times 5.5 times 6.4, and that is 362 points. Let me write it wrong. That's 362 point what? 56 meter cube per second. Then we come to Q3, which is 18.05 times 5.5 times 6.8. That is 675.07 meter cube per second. Then we come to this side, which is 8.65 times 3.5 times 10, and that'll give us 302.75 meter cube per second. Then we come to this section also, which is 4 times 3.5 times 10, and that is what? 420 meter cube per second. Then we come to the last section, which is what? 11.75 times 4 times what? 8. And that is what? 3,716. Now with this in place, we find the sum of each one of them. So I'll point to this side and find the sum of each one of them. So the total, the discharge, yes, I said earlier, is equal to the sum of the discharge for the K. So the total discharge is going to be Q1 plus Q2 plus Q3 plus Q4 plus Q5, then what? Plus what? Q6. And so the total will be equal to 85.2 plus 362.56 plus 675.07 plus 302.75 plus 420 plus 376, so plus what? 376. And that is going to give us what? Let's find out. So we're going to get a discharge of 2, 2, 21.58 meter cube per second. And that'll be the discharge. Discharge for the river. As simple as that. So you would want to um, go through the video once again to better understand how we got the section, and also if you want to know how we go about it for the mean section, you would want to check the next video out. Make sure to like, subscribe, and share this video if you think it's helpful to your colleagues and friends. See you another time. Bye.